Okay, we're going to continue. We're doing revision of, what is this? We're going to the next question. We are looking at the work that you guys were working on in term 1. And the next question comes from geometry. We got a lot of questions from you regarding geometry and tricks. So this one that you're going to look at is a geometry question. Remember, download our app as well. It's called Tenfold Education. This app will help you to cover a lot of the basics. I'm actually rushing now, guys, because we're out of time. I want to do as much as I can to show you as many answers as I can to as many questions that you guys sent us. So unfortunately, time is not enough. I hope in future we'll get more time to show you guys a lot of these things. That's why I'm rushing. I hope you're going to see what is going to happen now. So let's get right into it without any further waste of time. Okay, so the next one says to us here, in the diagram shown, triangle ABC with point D and F on BC and E a point on AC, such that EF is parallel to AD. So we see that these two lines are parallel. We can all see that. And we're also told that DE is parallel to BA. Furthermore, it is given that AE divided by EC equals 5 divided by 4. And the length of DF is equal to 20 centimeters. Okay, so we now have to calculate giving reasons, the length of FC, and we also need to find the length of BD. Okay, cool. So now, the only thing I can do in this question that we know, we definitely see that we can apply our proportionality theorem. That says if you've got a triangle and you've got a line that happens to be parallel to the third side of the triangle, then that line is going to divide the triangle into 2 equal proportions. So the ratio on one side will be equal to the ratio on the other side. That's essentially what that theorem says. And everything here is going to revolve around that. We were told that AE divided by EC happens to be 5 divided by 4. That doesn't mean that one is 5 centimeters and the other one is 4 centimeters. So what you always need to do is introduce a variable here. Call that 5K and call this one 4K. And come and put those there. So the length of this one, AE, I'll call that one 5K. And the length of this one, EC, I'm just going to call that 4K. Now with that, I am actually ready to start finding the answers to these questions. They want me to find FC. So I'm going to say to the examiner, the FC you're looking for, that FC. So FC divided by FD, right? FC divided by FD. This ratio, this divided by that, will just simply be equal to C. What's the hidden letter there? CE, yes. It's going to be CE divided by EA, right? And this is because we've got, we can call this proportionality theorem because we've got two lines that are parallel, and those lines happen to be EF being parallel to AD, right? And then I'm going to just start substituting whatever I know. FC, we don't know what FC is, but FD, we know that FD is 20. The other one, CE, is actually 4K. Yes, CE is 4K. So I've got 4K divided by 5K. The K's are going to simply cancel each other. They won't give you any problems. And then you cross multiply. This is going to say FC is equals to 4 times 20 divided by 5. And I think you guys will agree with me that 4 times 20 divided by 5 is 4 times 5. I don't have a calculator. I'm actually finding the answer without a calculator. It's actually 16 centimeters. That will be the length of FC. So FC is definitely going to be 16 centimeters. The other one we need to find is BD. So let's go and find BD. For BD, I'll apply the same technique. But if you go to BD, check where BD is. BD is the distance from B all the way to D. And I can actually focus on this triangle, the big triangle that you guys have in front of you there, the big triangle, and also paying attention to that this line happens to be parallel to that. So I'm going to take my ratios there. I'll say BD divided by DC. So BD divided by DC. So that's what I'm going to write. I'm going to say to the examiner, BD divided by DC equals to, let's check what that is going to be. BD divided by DC will be AE divided by EC. AE divided by EC. So it's going to be AE over EC, right? And the reason is because of the proportionality theorem. Since which lines are parallel now? Which lines are responsible for this? It's the line AB and ED. AB and ED, because AB is parallel to ED. That's why we can say this, right? And then from there, we can then substitute. Of course, you're looking for BD. So BD divided by DC is the sum. Look at that. DC is the sum of 20 and 16, which is actually 36, right? 20 and 16. That's what the other one is going to be. 20 and 16, that is actually 36, equals to 5k divided by 4k. And then if you simplify that in this small box here, you're going to have BD equals to 5 multiplied by, because the k's are going to simply cancel each other out, you'll have 5 times 36, right? 5 times 36 divided by 4. Allow me to be very sneaky here and undo that 36 and call it 5 times 9 times 4. Yes, divided by 4. And then those 4s will cancel. It's just 5 times 9. If you multiply 5 and 9, you're just going to get 45, right? That's the answer to the other one, right? It's going to give you a length of 45. So this is going to be 45 units. That's what we're dealing with here. Right. So let's go to the last part here. I'm going to keep writing the things I found. I just found that this one is 45. So I'm putting 45 here. And we also found that this one is 16. Right. The last part here is very, very important. And I wish we had more time to look at it. And we might not get a chance to focus on answering these questions. We are required to find the ratios of the area of triangle ECF and ABC. Right. ECF and ABC. Now, if you look there, ECF divided by ABC, let's go and look at them. ECF and ABC, the ratio of those two triangles. If you look at those two triangles, you'll see something very, very interesting there. Triangle ECF is this one here. And triangle ACD, it's the big one, this one here, that goes from here all the way to there, right? So we want you to find the ratios of those two triangles. So what you're simply going to do is acknowledge the fact that they're sharing a common angle. So when they share a common angle, you're going to apply the area rule to find the solution to this. So I'm going to say the first one is the one that is on top. It's going to be the area of the top triangle, the yellow one, area of triangle ECF divided by area of triangle ADC, right, will be half. One side there on the yellow triangle, we found this side here to be 4k. So that's 4k times the other one here was 16 sine of angle C, which is the angle between them, and the other one is half of the long distance here. Since this distance is also 5k, that makes it 9k multiplied by 20, and this is going to be 36 sine of the included angle, which is angle C. And then from there, you'll notice that half cancels half, sine C cancels sine C, k cancels k there, so I can get my calculator and say what is 4 multiplied by 16 divided by 9 multiplied by 36, and then the answer I'm getting is 16 over 81. So this becomes 16 over 81. Right. So I wish we had more time to do even more questions, because there was another one which was asking us to find the ratio of two triangles, but unfortunately we don't have time, guys. So in that case, if you've got those two triangles, you must find the ratios of sharing an angle. Use the area rule. But if they have the same height, because they share the same vertex, then you can use half base times height to find the solution. So thank you very much for joining us. A big shout out to Liberty. A big shout out to you guys for also watching the show. We'll be back with more tomorrow. Make sure you watch. And thank you for joining us. We'll see you again with mathematics on Thursdays. Till then, bye-bye.